Derivative of one function with respect to other function. Let's understand it by some examples. Suppose question is differentiate e power x with respect to sin x. Here we take first function as u. So u equal to e power x and second function as v equal to sin x. Now we differentiate them separately. Du upon dx equal to e power x, dv upon dx equal to cos x. Now we write du upon dv, which is equal to du upon dx divided by dv upon dx. Values. So e power x divided by cos x. Take another example. Differentiate e power root x with respect to root x. Again, we take u equal to e power root x and v equal to root x. We differentiate them separately. That is du upon dx equal to e power root x times derivative of root x, that is 1 upon 2 root x. And dv upon dx is equal to 1 upon 2 root. Now, du upon dv is equal to du upon dx divided by dv upon dx. We put the values e power root x divided by 2 root x times 1 upon 2 root x. So, 2. So it will become e power root x. Let's take next question. Question number 3. Differentiate sine square x with respect to e power cos x. So here we write u equal to sine square x and v equal to e power cos x. Now we differentiate. So du upon dx will be 2 sine x into derivative of sine x, that is cos x. Here, if you remember the rule, as I told you, d upon dx of function power n becomes n function n minus 1 into d upon dx of function. So here function is sine x, so 2 sine x into d upon dx of sine x, that is cos x. Here, dv upon dx will give e power cos x times derivative of cos x, that is minus sine x. Now, du upon dx will be equal to, sorry, not du upon dx, du upon dv equal to du upon dx whole divided by dv upon dx. And that will be equal to 2 sine x cos x divided by minus sin x times e power cos x. From where sin x will cancel out and we will be left with minus 2 cos x divided by e power cos x. Take one more example. Question number 4. Differentiate tan inverse x with respect to sine inverse x. So u equal to tan inverse x and v equal to sine inverse x. Now differentiate these two separately. So du upon dx gives 1 upon 1 plus x square, and dv upon dx gives 1 upon root of 1 minus x square. Now du upon dv, which is equal to du upon dx divided by dv upon dx. So it will become 1 upon 1 plus x square times root 1 minus x square, which is our answer. Now let's go to next point, derivatives of infinite series. Suppose we are given series like, say, y equal to x power x power x power x till infinity. So here we take this thing, x, this all thing as y. So we write it as y equal to x power y. Now we can take log on both sides. So log y equal to y log x. Now differentiating with respect to x, 1 upon y dy by dx. Here we apply product rule. Y into derivative of log x, that gives 1 upon x, plus log x into derivative of y, that is dy by dx. Now we take dy by dx terms together. So dy by dx times 1 upon y minus log x equal to y upon x. dy by dx 1 minus y log x upon y equal to y upon x, or dy by dx equals y square upon x times 1 minus y log x, which is our answer. Now let's take next question. Question number 2. Y equal to, suppose it is root sine x plus root sine x plus root sine x till infinity. So we can take this all as y. So y equal to root of sine. Here it is not minus sign. Don't get confused. Sine x plus y. Now we can square both sides. So it will become y square equal to sine x plus y. We can differentiate. So 2y dy by dx equals cos x plus dy by dx, or dy by dx 2y minus 1, this dy by dx is taken to LHS, is equal to cos x, which gives dy by dx equal to cos x divided by 2y minus 1. Now let's take another question. Question number 3. Suppose we are given y equal to e power x plus e power x plus e power x till infinity. In that case, this term can be taken as y. So y equal to e power x plus y. Now we can take log. So log y equal to x plus y. Reason, rule says, suppose we are given y equal to e power x and we take log. So log y will be x log e, and base is also e. So log e base e equal to 1. So the same thing has happened here. It would be, if we write it explicitly, so it will be log y equal to x plus y times log e base e, which is 1. So we get this thing log y equal to x plus y. Now we differentiate it. So 1 upon y dy by dx equal to 1 plus dy by dx. So 1 upon y dy by dx minus dy by dx equal to 1. So dy by dx common 1 upon y minus 1 equal to 1, which further implies dy by dx times, we take LCM, 1 minus y upon y equal to 1, or dy by dx equals y upon 1 minus y. Now let's take next question, question number 4. Suppose we are given y equal to a power x power a power x dot 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 till infinity. So here this whole thing we can take as y, this thing. So it will become y equal to a power x power y. Now we can take log, but we are going to use this property. Log a power m is equal to m log a. Here we can write it as y equal to a power x power y. So we are taking x power y as m. So log y equal to x power y times log a, where log a is a constant. So if we differentiate it, it will become 0. So we will treat it as a constant and we will differentiate x power y. But before that, let's take log once again. So log of log y equal to y log x plus log a. Now we differentiate. So differentiation of log y will become 1 upon log y times differentiation of log y. Here log y, keep in mind d upon dx of log of function is 1 upon function into d upon dx of function. Same rule. So here log of log y. So 1 upon log y times d upon dx of log y, that will give 1 upon y, then dy by dx equal to, here we apply product rule. So y into 1 upon x plus log x into dy by dx, and derivative of log a will be 0, so I'm not writing it. Now, so we can write dy by dx in one side, then 1 upon y log y, and from here it will be minus log x, when this term we shift to LCS, equal to y upon x. Now we take LCM. So it will become dy by dx y log y 1 minus y dot log y dot log x. Either we can put them in brackets, equals y upon x. Now, if we want to write dy by dx, then it will be dy by dx equal to y log, this is y log, it was y log y. So if we cross multiply it, so we will get y square. This y will get multiplied to this y square log y divided by x times. This all will become denominator. So 1 minus y log y times log x. So this is our answer. Dy by dx equal to y square log y divided by x times 1 minus y times log y times log x. Thank you for watching.